Hi guys, today I want to solve the problem which is the first order ODE by using separation of variables. So here's my question. dy over dx equal to y squared minus y multiply exponential x. Here's my initial value, y0 equal to 2. Okay, so let's start. From here, we just multiply dx, right, whole equation. So dy equal to y squared minus y exponential x dx, right? And then divide by y squared minus y, the whole equation. So 1 over y squared minus y dy equal to exponential x dx, right? So as you can see, this guy is just function of y for dy. So this guy is function of x for dx. So now we can do integration for this equation individually, right? So integrate the whole equation. Now 1 over y squared minus y dy equal to integral exponential x dx, right? So we can call this term is number 1 and this term is number 2. So just focus on number 1 first of all, right? So integral 1 over y squared minus y dy, right? So we can rewrite this one 1 over y minus 1 dy, right? So now we can use partial fraction for this term, right? What is a partial fraction? Partial fraction. Let 1 over a b equal to what? B minus a, 1 over b minus a, and 1 over a minus 1 over b. But there's some conditions, right? Which are a is not equal to 0 and b is not equal to 0 and a is not equal to b. Okay, so in this situation, what is a from here? Let the a is equal to y and b is equal to y minus 1, right? So a is not equal to 0 and b is also not equal to 0 and a is not equal to b, right? So to satisfy this condition, that's why we can use the partial fraction for this term, right? So y minus 1 minus y 1 over, right? And 1 over y minus 1 over y minus 1, right? So cancel each other. So 1 over y minus 1 minus 1 over y, right? So now we can rewrite the 1 over y multiply y minus 1 to 1 over y minus 1 minus 1 over y, right? So integral 1 over y minus 1 dy minus integral 1 over y dy, right? Now we can do integration individually. So natural log absolute value y minus 1 minus natural log y plus c1, right? So what about number 2? Number 2 is integral exponential x dx, right? So which is just exponential x plus c2, right? So now we can rewrite whole equation, natural log y minus 1 absolute value minus natural log y and plus c1 equal to exponential x plus c2, right? So we can write this term more simply, which is natural log y minus 1 over y, right, equal to exponential x plus b3. So in this situation, so c1 moved right here, so minus c1, and then we can call this term as c3, right? So y minus 1 over y equal to exponential x and plus c3. So y minus 1 over y equal to plus minus exponential d3 multiply exponential x. So now we can call this constant like k, right? So k multiply exponential x. Now we can multiply y to whole equation. So y minus 1 equal to k exponential x y, right? So we can rewrite 1 minus k exponential x y equal to 1, right? This term move right here and this term move to right here. So y equal to 1 over 1 minus k exponential x, right? But we still unknown the constants, which is k, right? Coefficients k, we don't know. So to find this value, we're going to use like initial value, which is y02 equal to 2 to find the value of k, right? So what is y0? Which means that we can put it 0 instead of x right here. So exponential 0 equal to 1, right? So this term will be just exponential, right? So 1 minus k e1, right? 1 over. Right? This guy equal to 2 from here, right? So 1 equal to 2, 1 minus k exponential, right? So 1 equal to 2 minus 2k e, right? So from this equation, what is k? K is equal to 1 over 2e, or 1 over 2e negative 1, right? So we found the value k. So now we can substitute this value to here, right? So what is y equal to 1 over 1 minus 1 over 2 exponential x minus 1, right? So we can multiply 2 over 2, more pretty answer, right? So 2 over 2 minus exponential x minus 1. So we find a value y equal to 2 over 2 minus exponential x minus 1, right? So this is our final solution. So that's about it. So if you got a lot of help, just press button like and subscribe. Thank you.